Hello and welcome to our lesson on adding and subtracting polynomials. So before we begin with our notes, a few things to keep in mind with this lesson. Number one is the idea of like terms are going to be very important. So we'll go over that in our next class meeting, but I would also encourage you, if you're not sure, to make sure you review the concept of like terms. The other thing that you'll notice in this lesson is that it is very heavy in vocabulary. So this first section with these different vocab terms is going to be crucial. So make sure you take good notes on this part and ask for help if you're not understanding these vocabulary terms. So the first vocab word that we're looking at in concept is the idea of a polynomial. So a polynomial we define as an expression which is the sum of terms. Now, a sum of terms could mean addition or subtraction, because subtraction technically is adding a negative. So an expression which is the sum of terms. Now, these expressions, again, are not equations, so they do not have equal signs, which you'll see in our examples below. So the first type of polynomial is known as a monomial. Mono being the prefix meaning one, so monomial, one term. So that would be something like x or 3. Just a single term on its own, or 5x. Then we have binomials. Binomials are two different terms. So it could be something like x plus 7 or 2y minus 4. The 2y is our first term, the negative 4 is our second. And then we have trinomials, prefix again, tri meaning 3, previous one, bi meaning 2. So a trinomial has 3 terms. So our example here, 3x plus y minus 8. 3x is one term, y is another, and the negative 8 is our third term. Then we have the following 3 vocab pieces: standard form, degree of a polynomial, and leading coefficient. So the first one, standard form, is when a polynomial is written where the terms are in descending order from the largest to the smallest exponent. So we're looking at our exponent values here, and you want to order them largest to smallest. Doesn't matter what the coefficient is. Remember, coefficient means the number or value in front of a variable. So in this case, our coefficient would be 4. Here it would be 8. So we order them largest to smallest exponent. So 4x squared plus 8x plus 3. Our exponents would be a 2, a 1, and a 0, because there is none. Then we have degree of a polynomial. So the degree of a polynomial is defined as the largest degree of all the terms. So if we look at each term as separate monomials, the largest degree, we're looking for the largest exponent value. So if our example is x to the 6 plus 4x to the third plus x, that would be the 6th degree, or degree of 6, because our largest exponent is 6. And then we have leading coefficients. So leading coefficient is the coefficient of the first term once the polynomial is in standard form. So you'll see as we practice, but our first step is always going to be to make sure our polynomials are in standard form. So once we're in standard form, the leading coefficient is the value out in front of that first variable. So in this case, it would be 9. So example 1 is practicing these different types of vocabulary terms. Now the type we'll go over. So we'll start though always with standard form. So standard form, we need to arrange it based on exponents. So I have x to the first, 3x to the fourth, a negative 11x to the third, and a negative 9. So when I rearrange 3x to the fourth, my largest exponent comes first. Minus 11x to the third, plus the x, and then minus the 9 for the negative 9 here. Then we have to identify our degree being the largest exponent value, in this case 4, so we have a degree of 4. The leading coefficient is the value out in front once we're in standard form. So in this case, 3 is our coefficient out in front. And then our types. So there is a table in the book scan that I'll include with this lesson, but our 4 main types that we're going to use are linear, quadratic, which you'll see lower down. We have quadratic, we have linear, we have cubic, and we have quartic. So the way we know these 4 different types, anything to a degree of 1, so if your degree is 1, you will always have a linear type, meaning it would create a line if we graphed it. Anything to the second degree, second power, is a quadratic. Anything where our degree is 3, so a degree of 3 is a cubic polynomial. And if we have a degree of 4, it is a quartic polynomial. So linear for 1, quadratic for 2, cubic for 3, quartic for 4. So looking at example B, we have 1 minus x. Rewriting that in standard form, the negative x comes out in front because it is to the first power, and then plus 1 because it's a positive 1. Our degree, x to the first power, so we'd have a degree of 1. Our leading coefficient is technically a negative 1 because it is a negative 1x, even though we don't put the 1 in front. And our type would be linear because it's the first power. Rewriting C in standard form, we end up with x squared minus 4x plus 3. Our degree is 2. Our leading coefficient, we want to know what's in front of the x squared. So if we don't write anything, it's 1, because it's 1x squared. And our type would be quadratic. For D, we have a negative 5x, so we just have our monomial. Rewriting that in standard form, still negative 5x. Degree of 1, leading coefficient of the negative 5, and our type is linear. And then our last 2 here, for E, in standard form, we need to flip the negative 8 and the plus x. So it becomes 5x cubed minus 3x squared plus 4x minus 8. Our degree, our highest exponent is 3. Our leading coefficient, what's in front of our first term, is 5. And because it's the third degree, it is cubic. And our last example on this page, F. For F, we have 2 minus x to the fourth plus 2x cubed. So if we rearrange, we have to put our negative x to the fourth in front, plus 2x to the third, plus 2. Our degree would be a 4, our leading coefficient of -1, and our type, because it's the fourth degree, would be quartic. So once we've established all the vocabulary terms, we then can start to add or subtract polynomials. Now, the way that we add or subtract polynomials can be simplified to the idea of combining like terms. Now, like terms, which we'll go over, means they have to have the same exponent and the same degree or variable, or I should say, degree and exponent and the same variable. So, same variable and the same exponent to be a like term. Coefficient out in front doesn't matter. That's what we'll be adding or subtracting. So if we look at A, I have 4x squared plus 5x minus 8. So I have an x squared, an x, and no variable. So 3 different terms. My like terms, which I color-coded here, the negative 2x squared can be combined with 4x squared because they have the same variable and the same exponent. So we look at our sign in between addition. 4 plus -2 is 2, so 2x squared. A 5x and a positive 3x being added would give us 8x. And then a -8 plus a positive 6 would be a -2. So in B, we have 2x to the 6 minus x to the 5th plus 3x to the 3rd minus 14x squared plus 13. Then our second polynomial that we're adding is 7x to the 5th minus x to the 4th plus 9x to the 3rd plus 13x squared plus 2. So both of these are already written in standard form, which makes our life easier. 2x to the 6, no like terms in this polynomial, so it has nothing to combine with. It stays 2x to the 6. Then we have a -x to the 5th and a positive 7x to the 5th. So a positive 7 plus -1 is 6x to the 5th. Then there is no x to the 4th here, but we have a -x to the 4th here. So that just comes down as minus x to the 4th. Plus 3x to the 3rd, and the plus 9x cubed, or to the 3rd, becomes plus 12x to the 3rd. Minus 14x squared, and a positive 13x squared leaves us with a -1x squared. And then 13 plus 2 gives us 15. So in C, the first thing I do is check to see if they're in standard form. Neither of these are in standard form. So you can see here in green, I just rewrote these polynomials to put them in standard form. That makes identifying and looking for like terms a lot easier. X to the 5th is nothing, so it just stays x to the 5th. -2x to the 4th has nothing to combine with, so it comes down. -3x cubed, positive 7x cubed gives us 4x cubed. A positive 11x, a -8x, so 11x minus 8x is 3x, plus 8x would give us 11x, and then a positive 2 and a -3 gives us a -1. And our last addition example here for the sums with D, already in standard form, so I'm just going to look to combine like terms. 7x to the fourth just comes down. A -x cubed and a positive 9x cubed leaves us with 8x cubed. -5x squared and a positive 13x squared leaves us with positive 8x squared. The plus x just comes down, and a -1 and positive 2 leaves us with a -1. Now, to find the difference, it's the same rule of combining like terms, but now you have to apply the subtraction to each term in this second polynomial. So what I mean by that is combining like terms here of 3x squared minus 5x squared. So a 3x squared minus 5x squared gives us a -2x squared. A -7x minus 3x is a -10x. Positive 5 minus -6, so that becomes +6. So positive 5 minus -6, same as 5 plus 6, which gives us the +11. So in B, 11x to the fourth minus a -1x to the fourth becomes 11x to the fourth plus x to the fourth, or 12x to the fourth. X cubed, nothing to combine with, so it's just x cubed. -x squared doesn't have anything to combine with, but it becomes a plus x squared because if we're looking at our problem, we're subtracting a -x squared, which turns it back to a positive. Then -x minus 2x gives us -3x. Positive 5 minus 8 gives us a -3. So in C, what I'm looking at first is, in this problem, 11x minus 8x, I can combine right away to become 3x. Then I'm going to combine like terms. I have a -3x cubed. I have an 11x in the 8x, which became 3x, an x to the fifth, and a +2. So x to the fifth, being our highest degree, has nothing to combine with here, so it's just x to the fifth. Then, nothing to the fourth in our term on the left, so this becomes, instead of a minus 2x to the fourth, minus a negative makes it a positive. Then with the thirds, -3x to the third minus 7x to the third would give us a -10x to the third. -12x squared came from just this 12x squared here, but it's a positive, but remember we're subtracting, so nothing minus 12x squared would be a -12x squared. 3x minus 8x would be a -5x, and then 2 minus a -3 would be a +5. And in D, we have a -3, or a -x cubed, a -5x squared, plus x plus 1, and then minus a -x cubed, plus 3x squared, plus 10x minus 9. The -3x cubed minus a negative 3x cubed becomes addition, and those cancel to be 0. Negative 5x squared minus 3x squared should be, and I wrote this wrong, negative 5x squared minus 3x squared. So a negative 5 minus 3 more, that should be a negative 8x squared, not a negative 3. So negative 8x squared of x minus 9, or minus 10x, gives us a negative 9x, and a negative 1 minus a negative 9. Negative 1 plus 9 gives us a plus 8.